Hey everyone, and welcome to The Explainer. I am so thrilled to have you here today because we are diving into one of the absolute most vital skills in software development, mastering program survival. Look, if you've ever written a line of code, you know the real world is messy. Users definitely do not always behave the way we expect them to, right? So today we're building an impenetrable defense. We're going to create a step-by-step tutorial on how to prevent those frustrating program crashes using try and catch blocks. Think about this for a second. What actually happens when your code encounters something completely unexpected? You know that sinking feeling. You've built this beautiful, totally functional application, and then someone accidentally types a word instead of a number into a form. Poof. The application just vanishes. It crashes. But why exactly does that happen? And more importantly, how do we stop it dead in its tracks? Well, here is our roadmap for today's explainer to figure that out. First, anatomy of a crash. Then, introducing the safety net, followed by step-by-step crash prevention. After that, catching multiple exceptions, throwing your own exceptions, and we'll wrap it all up with the finally block. Let's get into it.
Okay, Section 1, Anatomy of a Crash, when code fails. Let's identify the real villain of our story. The technical term for this villain? An exception. Basically, an exception is just an unexpected incident that completely stops the normal execution of your program. It's exactly what it sounds like, an exceptional event. When a program receives invalid user input, it simply doesn't intuitively know how to handle it. Without specific instructions, the program just throws its hands up, gives up, and dies.
To put that into perspective, imagine your code expects a number, but receives a word instead. That triggers an unhandled input mismatch exception. And when that mismatch occurs, execution abruptly ends. The program literally stops in its tracks. Game over.
And that brings us to the core contrast we absolutely have to understand today. On one side, we have the unhandled exception. Program execution immediately stops and exits. On the other side, the handled exception. This is where a safe error message prints and execution smoothly continues. This right here is our main goal today, folks. We want to completely eliminate that fatal stop.
Which brings us to Section 2, introducing the safety net, try and catch. Let's meet the heroes that are going to save our code. Setting up our code to survive is remarkably similar to setting up a high-wire trapeze act. I mean, you wouldn't let an acrobat perform without a net, right? Well, your code is the exact same way. Here's the essential 3-step playbook. Step 1, identify the risky code. That's your acrobat. Step 2, wrap it in a try block. You're basically telling the program to just try this risky stunt. And step 3, deploy the catch block handler right underneath it. That is your safety net, waiting to catch the acrobat if things go sideways. Moving right along to Section 3, step-by-step crash prevention, implementing the blocks. Let's actually look at how this structure works in practice. The visual relationship here is key. You take your normal, potentially risky operations, and you physically wrap them inside that top block, the try block. And sitting patiently right beneath it is our security measure, the catch block. By structuring our programs this way, we are intentionally separating the risky behavior from the emergency response. And this brilliantly illustrates the flow. The try block surrounds the code that might fail. If everything goes well, awesome. But if an error occurs, the try block exits immediately. Execution jumps instantly out of danger and straight into the safe embrace of that catch block handler. Because it anticipates that specific thrown error, the code within the catch block executes safely. Crisis averted, and your program survives. Now, on to Section 4, catching multiple exceptions, handling different threats. Because let's be real, the real world is rarely just one type of danger. You are definitely not limited to just one safety net. A single try block can actually have multiple catch blocks stacked right underneath it. Each one handles a different, highly specific error type. When an exception occurs, the code sequentially checks each net, top to bottom, and jumps to the very first matching handler it finds. Now, at the very bottom of the stack, you can place the generic exception base type. That acts as a massive net that catches absolutely everything else. But I've got to warn you about using that massive generic net too early. If you use that generic catch-all exception net right away, you might accidentally trap completely unintended errors. For instance, say a user types the word 7, triggering an input mismatch exception. If you use the broad exception type catch block, the program blindly catches it, even if you only intended to handle a completely different math error there. Using a catch-all net masks real issues. The golden rule here? Always catch specific exceptions first.
Section 5. Throwing your own exceptions. Taking control. Up until now, we've just been reacting to errors, but sometimes you need to be the one sounding the alarm. Check out this logic. Imagine your program calculates a mix ratio, and it explicitly checks if the result is not a number. If it is, instead of just waiting around for a messy system crash, the code intentionally uses a throw statement to create a user-defined exception. You are literally forcing the safety net to deploy whenever your program's custom logic is violated. That is taking total control.
So, what if a specific piece of code detects an error, but it really doesn't want to handle the cleanup itself? It just passes the buck using a throws clause. The code essentially says, hey, I generated an error, but I'm tossing it over to the calling code to handle. It's a fantastic way to keep your error detecting completely separate from your error handling.
All right, Section 6, the finally block, the unskippable step. We have tried, we have caught, and we have thrown. Let's look at our absolute final layer of reliability. Think of the finally block as your unskippable cleanup crew. This block always executes when a try block exits. Actually, it doesn't matter at all if the trapeze stunt succeeded perfectly or if the acrobat fell and triggered the catch block. The finally block runs regardless. That makes it the perfect place for crucial additional processing, like safely closing files or releasing system resources so your computer doesn't get bogged down. It's your ironclad guarantee that no matter what chaos happens, the floor gets swept.
Wow, we've covered a ton of ground today, right? From the anatomy of a crash to the impenetrable safety of try, catch, throw, and finally blocks. If there's one core philosophy I want you to take away from this explainer today, it is this. Good programmers don't just write code that works under perfect conditions, they write resilient code that survives the unexpected. By anticipating those failures and structuring your safety nets properly, you take complete control of your application's destiny. So I wanted to leave you with this question to chew on. What fragile parts of your own code could really use a safety net today? Think about that form field you built last week, or maybe that file import script that's been acting a little wonky. Go back to your code, find those risky acrobats, and put your brand new try and catch skills to work. Thank you so much for hanging out with me on this explainer, and happy coding!